You have studied that light and sound waves can be reflected. In reality, all waves can be reflected. Okay, so let's look at wavefronts first. Okay, so the phenomena of reflected waves can be studied with the help of a ripple tank. Do you know what a ripple tank is? So I'll show you what a ripple tank is. Okay, so what you see in the diagram. So now this is a view from a side view of the ripple tank, water ripple tank. So it's water. So all points along line AB are in phase, and these are the points of the same distance from the source of vibration, and they have the same displacement. Therefore, line AB, which joins the points in phase, okay, in phase. In phase means sama fasa in a wave is known as wavefront. Okay, same goes for line CD. Line CD is also known as a wavefront. When light rays move through water in a ripple tank, alternate bright and dark fringes can be seen. So you see in the diagram the formation of bright and dark fringes alternately. It's like the light rays travel through concave and convex lens. Okay? The light rays converge, diverge, and then that forms dark fringes and bright fringes alternately. Okay, see, and then the next figure shows the wavefronts for plane waves and circular waves. Okay, so let's observe these two diagrams to make sure you know the difference. Or are there any difference? Okay, so for the plane wavefront, okay, look at the line of propagation. So when you draw the line of propagation, you must have an arrow, and the line of propagation is perpendicular to the wavefront. And same goes for circular wavefront. Okay, the line of propagations are all perpendicular to the wavefront. And another important point to note is all wavelengths are the same. Okay, so if you are asked to draw, you must make sure the distance between each line is the same. Okay, so what is the effect of the characteristics of waves when a wave is reflected? So in order to explain this one or to study this, we should do an activity. If you can, since we are at home, so you can go to your toilet, or to the kitchen and pick a basin and fill it water, and you can carry out your investigation. Okay, so here is the short video of the reflection of waves or plane waves.
So this is the circular wave. Okay, so the circular wave. So you see the wavelength are all the same. So this is the incident, and these are the reflection of it. So if I place the source down, so here is the reflector. This is the reflector, this is the source, so this is the incident. Okay, so these are the reflected wave. Okay, so what about plane wave? Right, so now, okay, this is the incident wave. Okay, and then they reflect, it will be reflected. So you see this is the phenomenon, and you see the distance are all the same because they have the same wavelength. And here the angle incident and reflected angle at the same.
This is the simulation, online simulation, but you can have a look at this in the lab. We can use ripple time to observe this. Now, activities, the diagram here, a shot of a diagram of the water waves, the reflection of water waves. Right. Now, if you look at this diagram, first I want you to compare the angle of incident and angle of reflection. Okay. Now, from the incident wavefront, okay, so you can see the line of propagation of incident wave, and then it goes to the normal line, and then there will be there is reflected wave propagation. So when you draw, you must make sure the angle of incident and angle of reflection is the same. What about the incident wavelength and the reflected wavelength? So if you see in the diagram, those are the same. They are not changing before reflection and after reflection. So how can we get this diagram? So actually we can get this kind of diagram by using stroboscope. Okay, stroboscope is used to freeze the movement of incident waves. So this is a stroboscope. Now, from this activity, we can summarize the effects of reflection on the characteristics of waves. So we have discussed about the angle of incidence and angle of reflection. They are the same, not changing. What about wavelength? Yes, wavelength also will not change before reflection and after reflection. Frequency also remains the same before and after reflection. So since wavelength and frequency are not changing, the wave speed will not change as well. The only thing that changing during reflection is the direction of propagation. Okay, the next important part is the drawing part. Okay, drawing diagram of reflection of water waves. Okay, so everyone need to know this. Okay, this is also important. So once we learned the theory just now that the angle of incident is equal to the angle of reflection, and then the wavelength are the same. So we must know how to represent that in diagram form or in drawing form. So you have plane reflector, and then you have incident wave. So first, the step number 1, you must draw an arrowed line, and we can call the line AB. So this line must be perpendicular to the incident wavefront. So this represents the direction of propagation of incident wave. Okay, step number 2, you draw the normal BN. Okay, you cannot forget this one. So a normal line must always perpendicular to the surface. Okay, step 3, you must draw an arrow BC. We call this BC. From point B, we draw a straight line to C. Okay, but we must make sure the angle ABN is equal to the angle NBC. Okay, same. And then final step, you draw the line that we want, which is the reflected wavefront. So what we learned just now? Yes, you must make sure the line of wavefronts are perpendicular to the line of propagation, and each line has the same distance between each other. Okay, that tells us about the wavelength. Okay, you cannot draw one big distance, one small distance. They have equal distance. Okay. Okay, next we want to look at the applications of reflection of waves in daily life. Okay. First, ultrasonic waves that are used in the medical field. Okay. So for example, to examine a fetus, okay, baby inside the womb, or other internal organs. And then we have radio waves, okay, from communication satellites. Okay, so this is we apply the knowledge of reflection of waves. And then we have technology, sonar technology. The sonar technology, it helps to detect areas which have a lot of fish. Sometimes if you want to know the depth of water, we also use sonar. Okay. And in oil and gas fields, if we want to find the location of oil and gas, we can use sonar. And we apply the concept of reflection of waves. So knowing all this, okay, we can use this knowledge to do calculation about the depth. So what's the formula? Actually, it's just the same as the straight line kinematic formula. So it's just that for reflected of sound wave, we use the formula depth equals to Vt over 2. Y over 2. Because once the wave is transmitted, it will be received. So the sound wave travels twice of the same path. Okay, so here is an example of question. The figure shows the use of ultrasonic waves by a ship to determine the depth of the sea. To determine the depth, so you are given the time, which is 0.0 seconds. So, but make sure you read carefully. Yeah. So the time given is the time between transmission and receiving. Okay. So. And then the speed is 1,500 meters per second. So you just write the formula and plug in the numbers together.
So what's the depth of the sea? The interval time between transmission and receiving. So the time is 0.06 seconds. Speed of the ultrasonic wave in the water is, it's given speed v, the symbol is v, is given as 1,500 meter per second. So determine the depth. So just now we have look at the formula. So you write the formula here, equals to Vt over 2. Alright. So why 2? Because the time from here and then reflected back. So twice of the depth. So we just substitute the values. And time 0.06.
Okay. And use your calculator. Therefore, the depth of the sea is 35 meters. Hopefully you enjoy what you learned today, and inshallah this will be benefit to you, and maybe you can apply this in your daily life. Okay, so see you again next time. Don't forget to answer the quiz. Okay, this will be open only today. Click the link to answer the quiz. Alright.